This is a solution to problem number 95 from Homework 6.1 Day 3. Here we're asked to convert from linear speed to angular speed, actually. So it says a car is moving at a rate of 65 miles per hour and the diameter of its wheel is 2.5 feet. So I've sketched the wheel here. The diameter is 2.5 feet, which means the radius would be half of that. 1.25 feet equals the radius. And we're asked to find, in part A, the number of revolutions per minute that the wheels are rotating. So eventually we want to get to revolutions per minute. And we're beginning with miles per hour. So we're beginning with the linear speed and we're going to an angular speed. So I'm going to start here. We know that we have 65 miles per hour. And we want to get to revolutions per minute. So first, let's go from hours to minutes. So in 1 hour, I'm going to put hour in the numerator because I have hour in the denominator in the previous ratio. In 1 hour, there are 60 minutes. So now we're in minutes, which is the desired unit for the denominator. And now we have to go from miles to revolutions. So from the linear measurement to the angular measurement. So how are we going to do that? Let's get from miles to feet only because the diameter and radius are given in terms of feet. So in 1 mile, there are 5,280 feet. And now we no longer have miles, but we have feet per minute. And then the key conversion here is to go from feet to revolutions. And for that, we're going to use the idea that in 1 revolution, the wheel travels 1 circumference, which is 2 pi r or pi d. So here we can say that the wheel is going to travel the circumference. So I'll put that down here. The circumference is 2 pi r or simply pi d. So that's going to be pi times 2.5, or if you want to think of it as 2 pi r, you can do 2 pi times 1.25. That will be the same. And then it travels the circumference per revolution. So in the numerator, I'm going to put 1 revolution. And now we can cancel out. This has the unit of feet. So I'm going to cancel out the feet. And now our units are revolution per minute, which is the desired unit. Now we have a series of ratios, so multiply across the numerators and then divide that by the product of the denominators. And if you multiply that out, you will find out that this value is equal to 728.3 RPM, which is the same thing as revolution per minute. In part B, we're asked to find the angular speed of the wheels in radians per minute. So we're converting from 1 unit of angular speed. So we're going from revolutions per minute to radians per minute. So it's 1 unit of angular speed to another, that conversion. So I'm going to begin with my answer from part A. So this wheel is traveling 728.3 revolutions per minute. And now to convert that to radians per minute, I need to use this conversion factor that in 1 revolution, there are 2 pi radians. And now we've gone from revolutions per minute to radians per minute. And if you multiply 728.3 times 2 pi, this turns out to be 4,576 radians per minute.